Hello everyone, this is Nicole and this is Lab 3.4, Ocean Acidification. Ocean acidification is the decrease of pH and increase in acidity caused by the increase of CO2 that we put into the atmosphere. When the oceans absorb the CO2, the carbon dioxide, they become more acidic, which causes a depletion of carbonate, which is needed by the marine life, the coral, plankton, the small sea animals. It's needed for them to grow and maintain their structure, the coral structure, as well as for the sea animals to maintain their shells. It is said that even if we as humans do stop emitting all the carbon dioxide, the oceans would continue to acidify because we've already loaded so much into the air and they are the sink that catches all of it. It's still a concern. Either way, I think we gotta do what we can while we can. It can cause extinction of certain sea animals. If it were to get really bad, it would kill the plankton that feed our larger animals because they are the bottom of the food web. They support the whales, krill, tuna, etc. So either way, even if it won't make a big difference, I still believe that we have to do what we can while we can. So I already created my pH by chopping up half of a cabbage and pouring it into the pot, covering it with water and boiling it. I need to lower this a little so you can see. Okay, so there is the pH. And next, what we're going to do is I created plastic cups for each of my chemicals. I decided to do ammonia, baking soda. I went for lemon juice as well as soda and vinegar. I decided to do a bunch of them. So I'm going to put a teaspoon of the pH indicator into each of my cups. Which really isn't a whole lot. I am using a half of a teaspoon to make a whole teaspoon. Okay. And then next, we're going to add a half a cup of water into each of my cups. And then we will pour a little bit of each substance into each of the cups. So let's start with ammonia. Again, it does make it fairly light. I'm trying to get in the most camera here with the cup. And the way the light's hitting us. So we're going to pull them up as I do. And again, here's the cup that we're going to do the ammonia. So, I'm going to add a little bit more of the pH in there. ammonia. It's new, we picked it up for the experiments. Wow. Mix it up. That was a pretty big reaction. Okay, so as you can see, it's more of a green color. Ammonia is white, so it definitely reacted. And then the next one we have, we're going to do the baking soda. I'm going to sit up here because it's easier. So we have the baking soda next. And again, we've got to open this because we also bought it for the experiment. And I'm just going to add a little quarter of a teaspoon here. And there's my baking soda. It turned it more of like a really light blue color. And then next we have vinegar, which is an acid. The baking soda and the ammonia were obviously bases. So let's add a little bit of the vinegar. Oops, that's the ammonia that we just used. So let's add the vinegar, which is again the acid. In which it causes it to turn purple. Oof. Not really a fan of that smell. Purple. Let's lower this just a little bit more. Planning. So we'll back them up. So far we have the two bases and the vinegar. And our next one is going to be lemon juice, which is going to be another acid. That one as well. This is actually really interesting, and my kids had to go to school this morning, or they would be joining me right now as we work on it. It's actually quite pink. I think you can see as well on the camera. So, and last for our acids and bases, we have soda pop. We did lemon lime. And this one actually had the lightest reaction of all of them. So there's our acids and our bases, and of course our acids are going to turn more purple than our bases. Again, the lightest one was the lemon lime soda acid. Okay, and so now we are going to do the controlled and uncontrolled pH. Okay, so this one's going to be our controlled and our uncontrolled. And we're going to put 1 teaspoon of pH and 1 cup of water into each. water into each of these. To make my window bigger. See if that helps. Okay. So we have our control and our uncontrolled. And we're basically going to blow into this for 1 to 5 minutes and see the reaction. Amazing. You can actually see, even after that little bit of time, that there is indeed quite a bit of difference. This one's extremely light purple, and this one's still fairly clear. I'm going to get a piece of paper so that we can see a better difference. And my microphone is going crazy, so I do apologize. But you can see the difference. The one on the left that the carbon dioxide was blown into was greatly affected against the controlled one that just sat there. So we definitely do damage, and I think we just have to do our part to help out. And thank you guys. Take care.